All right, let's dive into one of the most common and honestly, one of the most important design decisions any C-sharp developer has to make. This is something that can really define the shape of your entire application.
We have all been here. You're staring at your screen, you're about to create a new type, and you hit this exact crossroads. Do I use an abstract class or do I use an interface? It's such a fundamental choice. Well, this is going to be your playbook for making the right call every single time. Our whole goal here is to take you from that feeling of confusion to absolute confidence. By the time we're done, you'll be designing C-sharp systems that are cleaner, way more testable, and just built to last. So to really solve this puzzle, we have to get to the heart of it, the core philosophy behind each one. And honestly, it all boils down to one super powerful distinction: a can-do versus an is-a relationship.
Okay, this slide right here, this simplifies everything. On one side, you have an interface. Think of it as a contract, all about capability. It only cares about what you can do. On the other side, an abstract class is all about identity. It defines what something is. Getting this fundamental split is the most crucial step, for sure. So the key thing to remember about an interface is that it's a promise. A great example is IEnumerable. Anything that implements it is promising that it can be enumerated. The system doesn't care if it's a list or an array or some custom thing you pulled from a database. They're all different, but they all share the capability of being looped over. That's the real power of can-do. Now, an abstract class, that's totally different. It sets up a family, kind of like a family tree. A dog and a cat could both come from an abstract animal class because a dog is an animal. They share a core identity and probably some common code, like a number of legs property. Think about the .NET Stream class. A file stream and a memory stream are both fundamentally streams. That's the is-a relationship right there. Okay, so we've got the theory down. That's great. But let's get practical. How do you use this in your day-to-day coding? Here are the real-world rules you can follow. You should absolutely reach for an interface when you're designing for flexibility. Remember, a class can implement a bunch of different interfaces, but it can only inherit from one class. So interfaces are perfect for creating these composable mix-and-match behaviors. They're the absolute cornerstone of modern dependency injection and loosely coupled systems. And hey, if you're building a public library or an API, an interface is the cleanest way to define that public contract without locking your users into your specific class structure.
So, when does an abstract class win? Well, it wins when you need to share implementation. I'm talking actual code and fields. That's its superpower. It's fantastic for defining a fixed workflow, like you see in the template method pattern, where the subclasses just have to fill in a few specific steps. It all goes back to that is-a idea. Types like shape or .NET Stream, they have this strong shared identity that an abstract class just captures perfectly.
Okay, so we've been talking about versus, this or that. But now for the pro move. The secret that really elevates your architecture from good to great is realizing you don't always have to choose. You can combine them. That's right. In the most robust, scalable, production-grade systems, interfaces and abstract classes aren't competitors. They're collaborators. When you use them together, you create this incredibly powerful and flexible pattern that gives you the best of both worlds: the loose coupling of interfaces with the shared code of abstract classes. So here's the blueprint. You start with an interface, let's say iNotificationSender. That's your public contract. This is what the rest of your app is going to know about and depend on. Then you can create an optional abstract class, something like NotificationSenderBase, that implements that interface and provides all the common boilerplate logic. And finally, your concrete classes, like Email Sender or SMS Sender, they just inherit from that base class and fill in the few specific details they need. It's clean, it's reusable, and it's perfectly testable. Whew, okay, we have covered a lot, so let's boil it all down into one final cheat sheet that you can mentally grab for your next project. And here it is, the quick chooser. For an interface, the core idea is can-do capability, making it perfect for composition. Use it when you need that loose coupling. For an abstract class, the core idea is an is-a relationship, making it ideal for inheritance. You use that when you need to share code and enforce a common workflow. It's really that simple. So the next time you go to create a new type, just pause for a second and use this playbook. Ask yourself, am I trying to define what this thing is, or am I defining what it can do? That simple question is your key to a much cleaner, more professional design. So, how are you going to use this to refactor your code